Hello, this is Dr. R. Chander, Assistant Professor, Department of EEE in Marri Reddy Institute of Technology and Management. Today, I would like to explain power quality and facts. That is the final year second sem subject. Now, the topic name is power quality and facts, and course code is 2280245. Now, I would like to explain power quality and facts and what are the power quality issues. One by one we will be discussed in this lecture. So, in power quality and facts subject having five units is there, but we will be discussed one by one. So, first unit is power quality problems in distribution system. So, in this video, we will be discuss and first unit topics, that is power quality and what are the power quality importance and poor power quality and what are the issues of power quality. So let us consider all peoples are talk about power quality or what is meant by quality of equipment, quality of life, so like this. What about quality of power? So we will be discuss simple example here. One bike is there and one petrol pump is there. So assume that the bike is depend upon petrol pump and petrol. So in this bike, the petrol is purely, then the bike will be run with what are the manufacturer are design. For example, 1 liter 40 kilometers there, and the maximum speed is 120 rpm. The manufacturer design. So the pure power or pure petrol is inside this bike. The bike will be start and run smoothly. Similarly, assume that in this pump, inside the water, mix the petrol pump, mix the petrol. What happened? So here, this petrol is inside this bike. The bike will be problem. Not started. In case of started, they cannot move, and the engine will be heated. And like this, that is the fault is not pure petrol is inside the bike. Another example is, let us consider, so this is the induction motor, whether single phase or three phase, and manufacturer are designed for three phase 415 volts AC, 50 hertz frequency, and some amplitude is there, fixed amplitude is there. The manufacturer designed some specifications. So here the purely sinusoidal voltage, and that means pure voltage is coming to from distribution to customer, or pure voltage is pure supply is connect to this induction motor. The induction motor will be run with what are the manufacturer's rated speed and voltage. The motor will be run. Otherwise, for example, instead of this sinusoidal wave, you can assume that you can apply this. So you see the right side of the another waveform. This applies this waveform is, or the voltage is give this induction motor. The induction motor will be cannot run. Why? Because the voltage is different and magnitude is different. And I can give the another simple example. So before that, what is meant by power quality? I will give the small and sweet definitions. That is, power quality is any problem manifested into voltage, current, or frequency deviation that result in misoperation or failures of the customer equipment. This is a very simple and sweet definition for power quality definition. That is, any problem in voltage or current or frequency deviation that results in misoperation or failures of the customer equipment. This is the very small definition for power quality. And one more thing is, so what are the problem for power quality? What are the important of power qualities? So here the power is cannot purely from generation to distribution, means customer. There are some issues is there, like malfunction of the equipment, overheating of the induction motors, and another one is single hours of downtime can causes million of money losses. These are the undercomes of the power quality issues. That is cannot come the purely power to the customer, to supply to the customer. For example, so here the power quality importance, another example is there. So here one is the hospital. So on hospital, the downtime could lead to losses of life. So that's why any hospitality or any industrial, they can arrange another sources, alternative sources. Next, coming to causes of poor qualities. So I will explain one by one. So first one is switch of the large loads. That means induction motors you can switch off or on. There will be some problem is there. Similarly, short circuit faults. And another one is unbalanced loads. And one more thing is the single phase on three phase system. There is mismatch the voltage and current and magnitude. And one more thing is non-linear loads. Also, these are the undercome the power quality issues or pure power and capacitor banks. These are the under the power quality issues. And one more thing is what are the issues of power quality. So assume that here first one is voltage shock, voltage swell, harmonic distortion and interharmonics, micro cuts, and under voltage, over voltage, and speaker and transients, voltage impedance are unbalanced. And last one is very important, poor power factor. So in this video, I will explain one by one. You can understand that. So first one is, so here the power quality issues. So this is the main power. So what are the issues? See here, under voltage and harmonics like flickers and unbalanced voltage cell, swag, transient and interruptions and frequency deviations. These are the undercomes the power quality issues. Next one is I will explain voltage swag in this lecture. So temporary reduce in RMS voltage 10 to 90%. Duration is 0.5 cycle to 1 minute and caused by fault or motor starting. So in this waveform, right side you can see the one waveform is there. That is, for example, this is the waveform. So this is the purely sinusoidal waveform. So for example, the voltage will be reduced. This is under comes the voltage shock. The duration is 0.5 to 1 minute. This is under comes the voltage shock. So what are the effects? The effect is malfunction of the electrical low voltage device and malfunction of the measuring and control units. These are the main effect of this voltage shock. Similarly, voltage swell. The temporary raising in RMS voltage 110 to 180% caused by sudden load remove. The induction motor or induction loads are can remove or start. So some fault is occur. It can be damage the sensitive equipment. So right side you can see the waveform. Similarly, I can draw the one waveform. This is the sinusoidal, pure sinusoidal voltage. So when you can remove your loads, then the waveform is like this, raising. This under comes the voltage swell. So caused by sudden load remove. So what are the effects? The main effect is malfunction of electrical low voltage device, and one more is malfunction of measuring and control units. These are the main effect of voltage swell. Next one is I will explain voltage interruptions. See here, I can draw the one waveform. You already see the waveform. That is complete losses of supply voltage. It can be momentary or temporary, caused by fault or production operation. See here, this is the waveform, pure sinusoidal waveform. Some the voltage is zero, is under come the voltage interruption. That is the complete loss of supply voltage. It can be momentary or temporary, caused by fault or production operations. Next, coming to under voltage and over voltage. So this is also here. This is the purely sinusoidal. So under the when the RMS dropped below 90% of normal RMS voltage and at the level of more than the 1 minute is under come the under voltage. See here, this is the purely sinusoidal wave. When the voltage is dropped like this, that is the when the RMS voltage drop below 90% of the normal RMS voltage and the more than the 1 minute is under come the under voltage. Similarly, over voltage, when the RMS voltage raising above the 110% of the normal RMS voltage and stay the level for more than the 1 minute. Like for example, I can draw the one waveform. This is the purely sinusoidal wave. So when sudden the voltage will be increased, raising like this. These are the under comes the over voltage. This is the over voltage. That is when the RMS voltage is raising above 110 of the normal RMS voltage and stay at the level for more than the 1 minute. This is the, you can call the over voltage. Next one is, I will explain unbalanced three-phase voltage. See here, in this waveform, there are three phases are there, R, Y, B, or A, B, C. So R, Y, B or A, B, C phases, the unbalanced means where A phase and B phase, there are no phase-to-phase voltages not equal and phase angle also different. For balancing three phase, the phase angle is 120 degrees. But in this waveform, unbalanced three-phase voltage means the A phase and C phase and B phase are not equal. Some mismatch is there. That is the unbalanced three-phase voltages. This is under comes the power quality issues. Next one is issues of power quality. So already discussed the above. So here this is the normal waveform, normal voltage. So when the voltage is decreased, then you can call the sag, voltage shock. When the voltage is raised above 110%, we can call the swell. And when the zero means off-stage. This already discussed above previous slides, and these are the references. Thank you.